Hi all, and today's the second series we are discussing about the space complexity. So I think you already aware about the time complexity, and the next session we want to discuss about the space complexity. Same as the time complexity, the space complexity also very important because each and every space as a data engineer side, as a data engineer's perspective, definitely we want to analyze how much data or how much space we definitely want to use a program. So the same thing we can think about, because as a programmer's perspective, as a client's perspective, everything we can look at. Actually, with the less time, less space, we want to store more efficient code. So that is the correct core concept of every programmer, right? So what is the space complexity? That means the time complexity is we already know total time is taken the all program to execute to the completion. So that is the time complexity. The space complexity means the total space taken to the program to execute, or when we write a code, the total space is needed to allocate those kind of code in the memory. So that is the amount is called the space complexity. So I think some people may misuse the auxiliary spaces also. The auxiliary space means extra spaces we are using in the algorithms. For example, like recursion. So that can we already saving some stack, right? We already saving some recursion step in a stack. So that's why it is recursively calling back to back. So that kind of thing is auxiliary space. So that the all space is needed to complete on a program is called a space complexity. So as a good developer, good engineer, we are aim to reduce the spaces and write an efficient code. Definitely we can write the efficient code, because just we need to understand where we can reduce the spaces and what are the things we can avoid. That means some kind of loops are taking more time or add more spaces, and some kind of variable we can reduce in some time. Okay, so that is the reason space complexity is very important. And I will discuss about, first thing I will discuss about the from the scratch. Everyone know 1 bit means 1 unit. Okay, 1 bit means 1 unit, and 1 byte equal to 8 bits. So this is the space. In the C we already know integer means it will store in a 4 byte string. That much, this much of space is needed. Okay, then you think about this is for one integer, right? If you store one core of integer, how many of space will require? Okay, that means a memory. This is the memory, so it will be storing from here, storing from here, storing from here. So this is a continuous process, right? So it will storing lot of data in the memory. So definitely we need to understand some kind of situation. We can avoid some variable, so it will reduce the memory sizes, and some kind of loops we can replace with the other loop that consume less spaces, so that we can understand. Okay, so that is the first concept. This definitely we want to know before understanding the space complexity. So every time you must remember it. So this much of space is needed for when we declare each and every variable and each and every loop. This much of space is needed. We can reduce it, and the total space is taken by an algorithm is called the space complexity. If space complexity is mainly depend upon the programming language. Actually, programming language C, C++, and Python, everything it is depend upon the programming languages and their machine performance. Okay, machine performance also important, and some of the learning algorithms. Some learning algorithms take only less space, but some will take lot of space. But that we will discuss later. Okay, what are the algorithm will take less space, what are the algorithm will take more space and faster output. So that kind of lot of criteria are there. So this is the one, and if you want to understand, for example, this is a one linear dimension, right? Only one dimension. So the space complexity required to store this array is n. So because of n is the space needed to store this much of data. For example, here for I in the range of 0 to n, for sum equal to, just want to run example. So the big O of n is the total space component. That means I to 0 to n iteration is needed. That much of element we want to store in the space allocation. So that is the reason it is big O of n. For example, you can see here it is a matrix. Okay, in the matrix it is 1, 2, and here 1, 2, 3. So this is n by 2, n by n. So that means the n square. The total space taken will be n square. So it depends upon the input size, right? So that here input is n into n, so that's why it is big O of n. Here the input is linear, so it is big O of n. This is n square, this is n. So this is the thing about the space complexity. So as a programmer, definitely we want to reduce the spaces. So yeah, so the coming forward we will discussing each and every program with the time and space complexity. You will get more understanding. So if you have any doubt, just comment below. I think I will already created one more lecture for this. You can use that link also. And the coming videos we can let's discuss each and every program, how to use, how the time complexity, space complexity, that kind of thing. Then bye.